Right, 2.4 Graphical Misrepresentations of Data. So we just want to look at where we can be deceived or misled if the graph of our data is done wrong. Okay. All right. So here's kind of just a general thought. Statistics is the only science that enables different experts using the same figures to draw different conclusions. So that's why we've got to be very careful about how we represent what we are looking at. Okay. All right, so our first misrepresentation here, we have this home security company. All right, and so it says when you leave for vacation, burglars leave for work. There's in Minneapolis, there's roughly 20% of home burglaries occur during the peak vacation months, and it's we have what's shown here. Okay. All right, so what's wrong with this? Well, when we look at all of these things, it doesn't give us the full percentages. Okay, we have 20% and 8%, but really we should have 100% total. That's 28%. So this here kind of gives us a wrong, misleading piece on those. So it may be 8% for each month, but that's not going to be clear in the way that they have this. Okay, and so it's very misleading on those pieces. And so here's what it really should look like. Now again, we could put some of those things together. July is still very high, but we want to make sure that we have the right comparison when we're looking at these pieces. Okay. All right, so here's another one. It talks about the marginal income tax rate. So right now it looks, we have this, that 2017 is much higher than 2018. But then we look at the numbers on the tax percentage and notice that we start at 36. And so that's going to be an issue here. We don't take into effect that we should be starting at 0 on those. And so if we start at 0, now our graphs don't look so far off. And so, yes, there might have been an increase or a decrease actually to go to 2018, but it wasn't as significant as the first graph led us to believe. All right, here we have a time series. So what might we be misrepresenting here as well? Okay, so when we look at this, we notice that from 2007 to 2014, the bar for 2014 is more than twice that of 2007 on those. Now, the reason that looks crazy is, again, our scaling. When we look at our number over there, we start at 30,000 instead of starting at 0 on those pieces. And so they're not chopping in those pieces there. So really we need to make sure the reader knows that really there's a big gap there that is missed on those. And so they've truncated it so we can see a little bit closer, but we need to understand that there's a huge gap of information missing on those pieces. Okay. All right, so maybe a better way of looking at that would have been the dot plot there on those, not dot plot, but I'm sorry, frequency polygon, so we can see some of those pieces and look at them a little bit better. Okay. All right, here it is looking at some of the toilet use, and so how people flush the toilet when we're looking at some public toiletries. So again, what's wrong with this graphic? Well, mainly looking at our percentages there with those. Each thing is kind of the same distance apart when that's not reality on those, okay? And so we want to make sure that we're paying attention to those heights and what it's representing on those. Is it a clear representation when we're doing those things? Okay. Here's another one when we look at the size. So it says that in 2010, we had 14 million participants, whereas in 2017, we only had 12 million. However, when we look at the size of the ball there, we would assume that 2010 was massively bigger than 2017, and that is not the case. Yeah, 2 million is a lot of people, but still, it's 12 million and, what was it, 14? Sorry, 12 million compared to 14 million is not that big of a difference on those, okay? And so we want to pay attention to those sizes and not make it where it's off. So a better way of representing that could have been through using the same size ball a bunch of times on those, so that we understand how much closer it is. All right. Three-dimensional. We try to avoid three-dimensional graphs. Yes, they look pretty, they look cool, but they are misleading on those pieces, okay? So when we look at this, it's hard to tell the size of those and which ones they are on those. And so we actually look at the data, things are either closer or further apart than they appear when we look at the three-dimensional, okay? So here, again, we're looking at that three-dimensional, and right now it looks like no degree and high school diploma, pretty close in size, but when we actually look at those, the high school diploma is much bigger. So we want to make sure that that representation is clear and polished on those things. And so that's why doing a two-dimensional graph is better, so we can see those pieces clearer. Okay. So a few guidelines. You want to make sure that your title and label are clearly providing explanations if needed. There's units of measurement. There's a data source when appropriate. Okay. Avoid distortion. Don't lie about the data. Minimize white space in the graph, and then use that available space to let the data stand out. Okay. If you truncate your scales, make sure you clearly indicate this to the reader so that they know what they're looking at. Avoid clutter, like a lot of grid lines or backgrounds and pictures that distract the reader. Try to avoid those types of things. Okay. Avoid three-dimensionals. They look great, but they often misrepresent the graphic. And then also try to avoid multiple designs, different design areas. Make us focus on a certain area compared to others. We want that data to speak for itself. Okay? And then finally, avoid relative graphs devoid of data or scale. Okay? We want to make sure that we have things that are clear and concise for us. Okay? All right, so those are the things that we're going to need here for 2.4.